Hi, thanks for joining. And I see a few folks that are actually coming on now.
Yep. All right, everyone. So just to start us off, my name is Ina Paricio, and I'm a marketing manager here at EDB. I will be your host today for a webinar, 5 questions to ask when moving Postgres to Microsoft Azure. I'm joined by Ashlyn Wright, Director of Product Management at EDB, and Benjamin Anderson, Cloud CTO at EDB. Before I turn it over to them, I just want to go over a few housekeeping items. First one is that this presentation is being recorded, so we will be sharing the recording along with the slides after the broadcast. And secondly, the lines are currently muted. So if you have any questions, please feel free to submit them in the question panel. We expect the presentation to last most of our time today, but we'll allow some extra time for Q&A. If we don't have time to answer all your questions, we'll follow up afterwards with any attendee whose question was not answered. So with that said, I will hand it over to Ashlyn and Benjamin to kick us off.
Great. Thank you, Ina. I'm excited to share a little bit with you all today, especially for folks that are looking to move Postgres workloads to Azure. So today we're going to walk through 5 scenarios that we're going to pose as questions, and we're excited to hear from you. So feel free to post questions to us, and we'll capture those at the end. All right, just to get started on the next slide. We get it, cloud is complicated, and wherever you are in the journey, whether you're sort of assessing or thinking about your cloud journey, maybe somewhere in the middle, you've likely realized by now that cloud can be quite complicated, and running databases in the cloud is no exception. In fact, it definitely adds a layer of complexity. So today we're going to actually walk through 5 different questions to kind of help you sort of think through what is important when actually assessing moving Postgres to the cloud. Ben, you want to go to the next slide? And the next one. So I'm going to dive into the first topic, security. Arguably one of the most critical considerations. And the central question that we're going to ask today is, how are you going to keep your databases secure? Next slide. So I would like to frame security in a few different areas. So I'll touch on identity and access management, and we'll also spend a little bit of time on network security as well. So one of the things that's important to recognize when looking at your Postgres workloads in Microsoft Azure, Azure Active Directory is the default solution for managing identities, and it's a critical service and integration point for you to be aware of depending on what you're using on premises. And I say that because it is the default. So you're likely going to be looking at some sort of integration point with it, whether you're using Active Directory today on premises or potentially another identity provider. With that, it's important to spend time understanding the account management hierarchy as well. For example, how accounts are related to each other, and how directories, subscriptions, resource groups, how do they all tie together, and what's the hierarchy of that structure? One of the things that I think is important to sort of take away from this is that Azure has specific constructs. So it's important to sort of get familiar, understand, learn them, but it's really important to standardize. I think looking at enterprises, running organizations, teams across the world, setting a standard for how different teams and orgs are going to actually interact with the accounts. The directories will be really important to achieve sort of scale. And I don't want to sort of understate that, but I think the base level of understanding will really help you start to frame kind of how you can actually standardize across your organizations with these account structures. So next, I'm gonna hand it over to Ben, and he's actually gonna talk through sort of the importance of managing, monitoring all of this access to your Azure account in the context of Postgres.
Thanks, Ashley. So first off, let's make this a little bit concrete, right? And I want to break this down between both control plane and data plane type activities. If you think about, a traditional IT data center type environment, obviously there's a spectrum there, but let's kind of take as a straw man something that's very traditional. You've got an IT department that's responsible for provisioning hosts, right? It's a very slow gated type process. You really have a pretty good understanding of who's got access to what and who's got control over what, because it's a traditional type process where you don't have a lot of automation. As soon as you go into Azure, you're going to, or any cloud, you're going to be looking at a situation where everybody's got a control plane sitting in front of them that can be used to provision new hosts, and it can also be used to destroy hosts, right? So you think about what you're doing with authorization and authentication in the context of Azure Active Directory, you ultimately have to be really careful because the risk ends up being really high. You make a mistake with your Azure Active Directory, and some random developer writing a script that they think is targeting development environments and deleting hosts can wander through and start deleting production hosts in production environments, and that's going to result in a pretty bad day, right? Furthermore, you know, regardless of what you're using on-prem, when you get to Azure, you're going to be using some variant of Azure Active Directory. Now, maybe you can federate with your on-prem identity management solution, but Azure thinks in Active Directory. Active Directory identities are really pervasive all the way down to the host level, or if you're in Kubernetes, in the pod level. Now, if you move over to the right side of here, you've got, let's say, a Spring Boot application talking to your Postgres cluster. You've got an application team that owns that Spring Boot application. Maybe in your on-prem environment, you actually had a nice setup where you're using LDAP, for example, to manage authentication and authorization for those applications. Maybe that LDAP was unified with the rest of your authentication system. Well, that's great, but once you're in Azure, now you've got a bit of a more complicated problem because the source of truth for authentication and authorization is Active Directory, and Postgres doesn't support Active Directory out of the box, right? So maybe you've gone from a slow-moving, more unified environment ultimately to an environment where you've got more people making more decisions, and those decisions ultimately have security implications, right? Do you need new processes to manage Postgres authentication? Do you need secondary controls and checks to make sure that at any given point in time, are my Active Directory roles and groups and permissions accurate? Are they accurately representing what I want users and automated systems to be able to do, right? It's just more complicated. There's more power. You can do a lot more things that are really fantastic if you're willing to invest the time, but it's not trivial, right? Moving on to network a little bit more, as Ashleen said, the network security is a hard problem. And no matter where you're coming from, when you get to Azure, you're moving to a very complicated software-defined networking architecture, right? If you've worked with networking, regardless of where you worked with it, network is hard. Networks are complicated. There's a lot of complex topics in there. And the cloud isn't really abstracting over those in a lot of cases. I think in a lot of cases, at least with Azure, they're actually making your job a little bit harder because they're offering different services that often overlap. So you might have 3 or 4 different ways to get traffic into your infrastructure, whether that's a front door, whether that's load balancers, whether that's VNet peering from another Azure account. There's a lot of different ways to get traffic into your account. And you need to make the right decision, particularly from a security perspective, setting aside performance and other things we'll talk about later, about how you actually want this architecture to fit together. You really need to start from the baseline. Okay, what do my virtual networks look like? What do the subnets look like? What sort of firewall rules do we want in place? What sort of security groups do we want to put in place? We've got this little word cloud here. This isn't a joke, and this is only maybe half of the networking constructs that exist in Azure. And they really all have security implications, right? you can't really afford to make mistakes here. You really have to come up with a plan, as Ashley said. Make sure that you've got a consistent plan. You don't have people just making things up because it's too easy to make things up. You've got all these toys that are just available via APIs. You can't just make it up. And you have to then check on a secondary basis, are we actually doing what we say we're going to do? If you think about that in a traditional environment, that might mean a quarterly firewall review, for example, which is nice. And a lot of organizations have that type of thing in their policies. But when you're in the cloud, you can do that sort of thing continuously. Set up a cron job that's checking network firewall configurations every 5 minutes, every hour, right? Continuously. Um, you've got, because it's fully automated, you've got a lot more power to really rethink the baseline of your security posture in terms of continuously verifying that you're doing what you want to be doing, what you say you want to be doing. And if there's any violation of that, obviously send a security event, and obviously lots of folks have pretty mature processes for that. Now that goes for anything, right? Application security, database security, but ultimately in a lot of ways, your data is the most important thing to think about from a security perspective. If you think about the sort of pillars of security, confidentiality, integrity, availability, the CIA triad, it's really about data, right? An application compromise can be a problem, but it's a problem because you're compromising the confidentiality or the integrity of your data. So really, at the end of the day, when you're thinking about cloud security, you've got to start with the data, right? You've got to start with the databases. You've got to start with Postgres, and you really have to understand how Postgres fits into your broader cloud, your cloud mission. I'm going to pass it back to Ashleen now to chat a little bit about performance.
So we touched on security, which is obviously a critical aspect of assessing sort of moving workloads. So the second piece that we want to touch on is performance, because one of the questions you're likely thinking about or asking yourself is like, what are the impacts, right, of moving to cloud? So for example, are my databases going to slow down when we move them to the cloud? It's really important to think through, because you've likely set performance expectations for your existing environment. And you're going to want to actually evaluate and take a look at different factors for what the impact would be when moving to cloud. So Ben, if you could go to the next slide, I'll touch a little bit more on the aspects of performance. So in the cloud, I think it's important to recognize that performance is closely tied to cost, but even more importantly, how fast you want to spend. And I wanted to frame it, in this sense of considering cost, because as a result, there's definitely some trade-offs, I think, to consider and sort of aspects to be aware of when looking at different factors of performance specifically. If you go to the next slide. So I'm going to step back a little bit. So touching on compute, looking at compute selection sort of between sort of an on-premises environment or cloud, there are quite large differences. So one of the things that you might be used to on premises is having every choice imaginable to you. In some ways, it's very complicated. You've got an endless, infinite amount of compute choices. Whereas in the cloud, in some ways, it's simplified, largely because there's a fixed amount of options. But it's important to consider that while sort of there's a fixed amount of options, some of the details are actually abstracted to you. So I'll share more later about what that actually looks like, but it's important to be aware of, because you don't necessarily know all of the details about each host, for instance. The other piece that I think is important to recognize is that, on premises, you might not have actually had any real opportunity to make changes or to sort of swap out infrastructure or compute selection. Whereas in the cloud, you really gain that flexibility, and you have an opportunity to make changes in an effort to actually spend less, right? So you're sort of given this opportunity with potentially achieving some cost savings that you otherwise might not have actually had the opportunity to do so in an on-premises environment. it's, one last point here, I think, is that it's important to note that when looking at compute, cloud isn't necessarily cheap. It can be quite expensive, especially at first. And we'll kind of take a few examples of that later on, but there are cost implications for performance, and it's important to actually know sort of your Postgres workload and then what that looks like when you're sort of looking at compute, storage, and all the options available to you. So with that, I'll go to the next slide to share some specific examples on the compute variants. So the next two slides, I touch on two different comparisons. So one is the memory optimized E-series. And what I did here, so sort of at an initial glance, actually when you go to Azure, look at instances, they look quite similar, but they have sort of the E-series, and there's an S variant, which I've captured on the below table. And at first glance, it can be kind of hard to actually assess, okay, what are the differences, right? What's the impact for me actually going to be on my workload, choosing between these two instance types? So I made some of the subtle highlights here just to kind of sort of highlight the actual differences themselves, but they're fairly subtle, but you don't necessarily know at first glance looking at instance types. So I think it's important to kind of assess your workload, what you might need, be cognizant of these sort of slight differences between instance types, and make sure that you take advantage of that ability to make changes, because one of the key pieces here is you don't necessarily know yet what the impact could be on your workload. So I'll just call out some of the key differences, but when looking at the S series, the S variant of the E series, for example, the support of premium storage is quite different between the two. There's a bursting ability difference. The temp storage, as you guys can see, is also quite different. So, sort of eyes wide open looking at this, it's important to recognize that, especially when choosing compute. And then on the next slide, I touch on the D series. And here, similar story, right? You can kind of see I've highlighted some of the differences, albeit you can see some of the deltas are actually even bigger. For example, the temp storage quite a bit bigger. And similarly on the D series, there's actually a different level of support in terms of the premium storage. So the first variant does not support it, the second does. In addition, there are actually some storage caching differences as well. So, these are things that are subtle, and at first glance, when you're actually assessing your workload, you might not even really recognize. So, Ben, if you go to the next slide, I think it's really important to kind of sort of take a step back and ask, okay, like you just showed me that, why do I care, right? Why do those differences matter? Well, when running a performant Postgres workload, those differences could actually have meaningful impacts. And it's important to make sure that you're cognizant of that while actually assessing instance types and ultimately choosing sort of the right compute for the workload. On the next slide, I'm going to touch a bit on storage. So we just sort of touch on some of the aspects of compute. And one of the other areas is storage. So Azure provides a variety of different storage types. You can see here there's sort of a myriad of selections. So I'm going to dig a little bit deeper and touch on premium SSDs and ultra disks, which I would argue a little bit more relevant in terms of sort of looking at a database workload. So on the next slide, what I'm going to share is a comparison. So looking at just a sort of a 1 terabyte workload with similar parameters set between the two, you can see here premium SSD compared with ultra disks, disk size, IOPS, the throughput, relatively similar, but the price is starkly different. And I think it's sort of important here to recognize that one of the big differences, which I'll sort of touch on later as well is that premium SSD and ultra disks are configured quite differently. And on ultra disks, you have the ability to actually tune some of those knobs and parameters, sort of scale IOPS up, scale IOPS down, scale throughput up, down. And I think from a price standpoint, that's important to know, right? Because you want to make sure that you're being cost conscious, but like still achieving that level of performance you need. So, I think it's important to recognize those differences between premium SSD and ultra disks, but ultimately, it can be quite hard to determine, okay, what's the right level for me, right? Like what are those right levels to actually tune? Because you don't really want to end up in a situation where you're sort of over consuming and paying the price. There's definitely a direct correlation there. So with that, I'm going to hand it over to Ben to talk through some of the
Yeah, sure.
configurations for local SSDs as well.
Yeah, on the premium SSD and ultra disks point as well, I think it's interesting to note too that obviously the ultra disks are a lot more expensive, and as Ashleen said, that they give you more configuration options, but they are fundamentally different technology under the hood. And just looking at the website, just looking at the spreadsheets, doesn't really give you a complete representation of the performance of these volumes. If you actually provisioned these two volumes and you were to go and run performance tests against them with something like FIO or something like that, you'll actually find that their latency distributions are wildly different. The way that Azure caps IOPS and manages the performance coming off of a host is different in UltraDisks and premium SSDs. So while the UltraDisk might look a lot more expensive, if you're going to be pushing the disk really hard, you're actually going to end up with a lower tail latency. Your sort of 99.99% latencies are going to actually be quite a bit lower for writes and reads coming off of the disk than they are with premium SSDs. So not only is it difficult to understand like what's going on just from a catalog perspective, but you can't set aside the fact that there is real technology over here that you're working with, and not everything is represented in the name difference and the knob difference between a premium SSD and an ultra disk. Now, the other big elephant in the room here is local volumes, right? A lot of folks that we work with who are coming from on-prem environments, coming from more traditional infrastructures, are 100% accustomed to using local volumes, right? They're using SSD or NVMe that's attached to the host that their database is running on. They get to the cloud, they get people telling them about premium SSDs and ultra disks and this and that and all these fun things. And at the end of the day, those are all network attached storage, right? Which is great for the cloud, right? You can terminate your VMs, you can do a lot of different things, you get fun snapshotting capabilities. But at the end of the day, it's attached, it's data somewhere else, right? You have speed of light problems with regard to the latency floor of your application, right? If your database needs to go really, really, really fast, the network attached storage might have trouble getting there. Now, this isn't 2006 or 2010 anymore, and there are good local attached storage options available in Azure. The LSB2 instance types have NVMEs. There's a lot of different choices of NVMEs. You still have to be careful because they're ephemeral. If you stop the VM, your data is gone, right? So going back to what I was talking about earlier, depending on who has access to your control plane, you have to be somewhat careful, or what your automation is doing, what permissions your automation is running under. You have to be careful. But the technology is there. Now, of course, if you're in cloud and you're saying, well, I want to see how fast these network attached storage volumes are versus local storage and see if the cost benefit, the performance trade-offs are worth it. You also have to remember that, again, these are real technologies with differences in how they behave, right? So things like optimal write queue lengths, for example, are very different from going from a premium SSD to an UltraDisk to an NVMe. And tuning your database workload is even more important, right? Any of this performance stuff that we're talking about, we've been bringing it to cost in a lot of cases because, as Ashleen said, it has a lot to do with how much you want to spend, because there is a lot of capacity in the cloud. Um, but the onus ends up on you even more than in a traditional environment to do rigorous performance testing and justify the cost decisions that you're making, right? That goes for compute and that goes for storage. And of course, performance tuning is hard, right? Um, I've been working in databases for a while. I've not seen a lot of organizations that are doing really rigorous experimental design-based performance tuning, in part because it's expensive, right? And in a lot of cases, it's only database organizations that really have the capacity in terms of the cost-benefit trade-off to do that type of testing, right? Um, it's hard to simulate your workload. It's hard to set up an experiment where you really control all the parameters properly to get a judgment between alter disk and a premium SSD, for example, for your workload. Or for example, between read cache and read write cache premium SSDs. There's just so many different parameters, and at the end of the day, they are computers sitting in data centers, or virtual machines sitting on computers and sitting in data centers that have real performance properties that you need to deal with, right? Would you prefer ARM workloads versus Intel workloads? It's complicated. With stateless applications, it's a lot easier, right? You just scale them up and down, you terminate one, you bring up another one, your load balancer is distributing traffic across things, across your estate without any problem. And that's easy, right? You don't really have problems. If you want to switch from one instance type to another instance type, it's easy to do an A/B test in a stateless application, especially if you're using something like Kubernetes. Uh, with databases, I imagine as everybody listening here knows, it's just harder than that, right? I can't count the number of times that I've had to explain to somebody that, like, dealing with stateful distributed systems is just harder than working with stateless systems. And I think that's doubly so for the types of work that you need to do to really understand your Postgres workloads in Azure in the cloud. Right? So, Ashley, do you want to chat about availability a bit?
Sure. So, next up in terms of considering availability, so the key question here is, what sorts of failures do you need to be able to tolerate? And if you go to the next slide, I'd like to frame availability by focusing on sort of the RPO and RTO requirements, so the recovery point objective and the recovery time objective. I think this provides sort of a good baseline for sort of decisions to consider, like in relation to performance and overall availability. So, thinking about things like how far can you go back and how long till you can recover. I think those are important questions, sort of frame how you look at availability. And with that, we're going to walk through an example. So Ben will kind of share an example of actually the considerations here for Postgres.
Yeah, so let's take something concrete, right? You're in a traditional on-prem environment. Let's say you've got a data center in San Francisco, you've got a data center in San Jose. They're physically isolated. You've got a Postgres running in each site. Postgres leader in San Francisco, Postgres replica in San Jose, streaming replication between the two. You're using synchronous replication, so you've got zero RPO, you got near zero RTO. They're close enough that the performance hit on the synchronous replication is not that bad, because of course you've got speed of light considerations. How long does it take for a packet to get from San Francisco to San Jose and back? So like this is a relatively mature on-prem environment. There's definitely people doing things that are a lot more complicated. There's also a lot of folks that are doing things less complicated, right, and less mature, right? But this is kind of works for a lot of people, and you can replicate this in the cloud. This is really easy. If this is the type of model that you want to get to in the cloud, you can do that, right? If you're not there yet, you can get there with the cloud. It's easy. So this is, you're going from kind of an on-prem environment world where you're thinking about sites as a heavyweight sort of construct, and for us to stand up infrastructure in a new data center would be very, very expensive, to the cloud, you've got a lot more freedom, and that makes these sorts of topologies a lot easier, right? Azure has a global infrastructure. They've got it says 100 regions, something like that. You have to be somewhat careful because everything that they call a region is not what, at least what I would call a region. Traditionally, taking from AWS, a region is a geographical area with a set, ideally 3 or more, of physically and logically isolated data centers called availability zones, right? So 2 availability zones are on independent power grids. 1 availability zone fails and it shouldn't affect the other availability zone. Ideally, you have 3 or more in every region. Azure plays some games. And so if you're moving to Azure, you have to be a little bit careful, right? Look really carefully at the difference between Azure's US East and US East 2 with regard to the availability zone topology and also what products are available. We were talking about UltraDisks a fair bit a little bit ago, and that's actually not available in all Azure regions. They roll out new features and new functionality. I think what they're actually doing is working slowly, across regions, and some regions are prioritized over others. I think there's actually newer tech in some of the newer regions, and that's how they're actually fitting things together. But going back to the example, the San Francisco data center and San Jose data center, put your data center in US. Let's set aside San Francisco. Let's move to the East Coast. Put your data in US East 2. You've got 2 availability zones. You put 1 replica in availability zone 1, 1 replica in availability zone 2, and you've got basically the same topology. And again, if you weren't doing that before, you're doing it now. It's great, right? Like your system has become more resilient to a broader class of failures. It gets a little bit more complicated though, and you start to get into some kind of tricky concerns. Let's say you've got an application team that's running a system on top of Kubernetes, or just spreading virtual machines across availability zones. Now, the folks running that group might be thinking, well, we can just spread our application across availability zones now rather than focusing in San Francisco where we were before, because that was our primary and then we all failed over to the secondary. Now let's think about our system as more of a mesh. We've got this region and we're going to be regional. We've got a bit of a problem now because your leader for Postgres is still in 1 and only 1 availability zone. So let's say in this diagram it's an AZ1. Your application teams are deploying software in AZ1, AZ2, and AZ3 and using a load balancer to spread traffic across 3. You've now introduced a latency hit that you didn't have before, because there's not 0 latency between availability zone 3 and availability zone 1. It's not milliseconds, usually measured on the order of hundreds of microseconds, something like that, ideally. But that's going to impact your applications in some cases, and you really have to understand the sort of availability performance trade-offs here. We talked about the trade-offs between performance and cost, talked about the trade-offs between availability and performance. These things are not independent, right? So you really have to understand that this isn't actually some sort of mesh magic. You're using Postgres. You have a leader, right? This gets even more complicated. We'll talk about as a service in a little bit, but this gets more complicated when you start to talk about platform as a service technologies, right? If you're using database as a service, you might not even know which zone your leader is in. So you couldn't avoid that latency hit even if you wanted to, right? So you really have to think, okay, well, how do I get the same properties that I wanted on-prem? Or how do I, even if I'm already working in the cloud, how do I ensure that I'm not doing unnecessary traffic transfers across zones and compromising my performance, right? Now, it is really nice to be able to take advantage of the global infrastructure that somebody like Azure provides. You can drop your backups trivially in a globally available object store, right? Use something like Barman, dump your backups in an object store. Now, if that complete region, if US East 2 is just completely gone, right? The eastern seaboard is flooded, whatever, some horrible situation, your backups are safe, right? Your backups are stored not just in US East, but they're also in US West and EU Central, for example. You can spin up infrastructure in another region. You can spin up databases in another region. You get your business back up and running, right? Obviously, this is not something that you should take lightly. It's not something that is, it requires DR planning and these sorts of things, but it's possible, right? It's possible and it's much, much easier than, again, if you were thinking about data centers as something that's expensive to stand up new footprint in. Furthermore, if you want to get more complicated and more sophisticated, technology like EDB's bidirectional replication can really help you run more sophisticated workloads, you start to think about regions, right? When you can have active capabilities, you can run active across zones, you can run active across regions, and you can start to break down the limitations of that single leader model in Postgres, right? A little bit more on the cross-region considerations as well. App developers tend to love this, and honestly, business people tend to love this as well. Business people see, well, okay, well now I've got access to all these regions. I want my system to just be durable to them. I want RTO 0 for a region failure, because it's easy, right? Look at these spec sheets and look at all these APIs. I should be able to do this. And again, it's hard in the database. It can be really expensive to fail a database across regions, right? You get a lot harder than it is to fail an application, right? Application developers will go and they'll talk to Akamai, and Akamai will sell them a global load balancer in 10 seconds, right? So it doesn't work for your database, right? You've got a single, setting aside something like BDR, you've got a single leader. That single leader is sitting in a single region. And when we're talking about regions, then we've got big speed of light considerations, 20 milliseconds, maybe 10 milliseconds between two Azure regions. If you want 0 RPO, you're going to take a 10 millisecond latency hit on every write. Can your application really afford that to get 0 RPO? And if it can't, then can you really fail over in case of regional failure that quickly in order to maintain business availability and business continuity? You end up in complicated decisions that are really tied up in the nature of your data, the nature of your database performance, and the nature of your business, right? If everything needs to be synchronous, RPO 0 really means RPO 0. You're going to have a hard time with cross-region considerations. And as a database person, you're going to have those conversations with your leadership because ultimately it just is sort of unavoidable. Ashley, you want to chat a bit about cost?
Sure. So taking the sort of fourth topic, one of the key questions that I think is definitely prevalent is, what should you be aware of when running Postgres on Azure, and sort of what those cost implications could be. So if you want to go to the next slide, I think it's important to recognize like sort of cloud costs in two frames. Like, it's expensive, but it's also transparent at the same time. So what I mean by that is, typically it's like you know what you'll be spending, or what you are spending, and I think as a result, there is definitely an added layer of pressure there, and in terms of sort of the reduction of costs. Like, you sort of get this insight into where the spend is going, and then that's going to yield or raise questions about, all right, how do we reduce this, and how do we sort of look at streamlining down that level of cost. I think there's a few things that are definitely worth calling out, just in terms of things that we've touched on previously, to be aware of. That, at first glance, when looking at Azure, these are things that you might not necessarily have gleaned or realized. But the first being on the storage side. So, we had obviously touched on the price difference between premium SSD and ultra disks. Because of how those two storage types actually differ, and the resulting cost implication of that, like it's super critical. It just be important of actually the trade-off in terms of what happens when you're increasing those knobs, what happens when you're tuning that storage, because there will be cost implications for that. So I think it's just important to sort of be aware of that, because it could have a meaningful impact. And second, on the networking piece, which is kind of interesting, I sort of find this like, it's sort of funny to me. It's almost footnoted. So, I think intercontinental data transfer fees, like that, by and large, from a cloud perspective, feels fairly standard, but it's definitely important. It's not something to trivialize. But the other piece that I wanted to call out is that Azure actually explicitly states, starting next year, they're going to charge for cross traffic in an availability zone. So, it's not prominently displayed necessarily, but this will definitely have an impact. And And it's also just a reminder, like they have the flexibility, they have the ability to make changes to different pricing, not just from a networking perspective, but across the board, right? And so I think those types of things, when looking at your workload, like don't necessarily get fixated on the compute costs, but make sure that when assessing, you're aware of the storage cost implications and the networking as well. And then lastly, I just wanted to touch on some of the managed services from more of a PaaS perspective. So like if you're looking at Azure Database for Postgres, for example, you know, the IOPS could be constrained by the VM type that you might be running. And as a result, there's a situation where you may actually have to provision a larger VM type to accommodate the level of IOPS that you require. And, it, we sort of look at it, you take a step back, and it's sort of potentially a lot of extra capacity, a lot of extra cost that you're incurring that you might not otherwise have really sort of thought about when you were originally sizing or sort of looking at your workload. So I think it's just coming back to this notion that it can be expensive, but there is a level of transparency, right? And you have control in terms of taking advantage of like where those nuances are. But there's some of the specific ones that we wanted to sort of call out, make awareness of as well. Ben, if you could go to the next slide. So shifting a bit, sort of wrap kind of all these sort of considerations up. Last question we wanted to pose is like, what about database as a service? Like, is this something to consider? So on the next slide, I think it's probably pretty common that most, if not all of you, are likely not in the database business. And therefore, a lot of the actual database operational sort of work is undifferentiated. It's not really where your core business is focused. And what I mean by that is you need, you're likely running sort of solid performant Postgres workloads, but you don't necessarily want to actually be in the business of database ops. And it's, it poses an interesting question because database as a service could be the right fit for you. And I think there's a few things to consider when actually looking at a database as a service offering. So if you go to the next slide, I'll share a little bit more on kind of an Azure point of view. And then I'll expand a bit more on the EDB side as well. So, Azure has a myriad of managed database as a service offerings. One of the interesting things before even sort of looking at Azure Database for Postgres is the level of investment that Microsoft has in SQL Server. You can sort of quickly glean from the myriad of sort of flavors and offering types that they have, i.e. like you can get managed SQL Server serverless, you can get managed SQL DBAS, you can get sort of managed SQL on IaaS. Like there's sort of a myriad of options. Within each of those tiers, there's extensive pricing options. And you can clearly sort of tell just in terms of like an initial assessment, there is definitely a high level investment there. And, taking a step back, like, looking then at what do they have for Postgres? Like what are the options there? It's I would say in general, sort of a bit of a contrast in terms of SQL Server, in terms of sort of the extensiveness. But that being said, there are some differences like within Postgres itself that are definitely important to be aware of. So, at a baseline, they have sort of 3 flavors, and the differences between those are actually fairly meaningful in terms of like what you might be assessing for your workload. So things like the version support, supported sizes, the SLAs, like all of those things are fairly different actually across these types. So, I think it's not necessarily a simple, straightforward answer. And it's important because you have to dig into the details, really sort of look at, for your workload, like what are the best fit for you? I wanted to sort of also share, on shifting gears onto the next topic as well. It's like, so how does, EDB fit into this? And, we sort of looked at 5 different questions, scenarios, spent a little bit of time looking at Azure's managed Postgres DBaaS. So where can actually EDB help? So, being the Postgres company, what our major goal is to support customers in any environment. So whether that means in a self-managed environment running on Azure IaaS, whether that means actually running in a DBaaS fashion. On the next slide, I'll share a little bit more about EDB's offering that we are about to go preview with for a database as a service offering. So EDB Cloud is a product that we'll be launching in the next few weeks. And this is a full database as a service offering. So just to touch on some of the key capabilities, we really think about this offering in terms of 3 pillars. So one is our Postgres expertise and our core differentiation in terms of compatibility with Oracle. And then lastly, continuous availability with BDR. And, looking at Postgres expertise, we are the Postgres company. We're driving the roadmap. We're working to apply all of this expertise to our database as a service. And with that, we're committed to customers to sort of bring the latest and greatest versions and make sure that there is break fix assurance for their workloads. I think it's an important aspect when looking at sort of running Postgres, because there are a lot of areas that our expertise helps sort of shore up some of the complications, right? We just laid out a whole bunch of questions, and some of those things can be fairly complicated to dig into, where our team is sort of not only focused on the Postgres expertise, but in the context of Azure, these are things that we've taken on and internalized to actually help you sort of successfully run your Postgres workloads. The second piece around Oracle compatibility, if you've heard of EDB before, you've likely known or sort of may be aware of the Oracle compatibility that we have. It's something that we've been doing for a long time, but it does solve a big problem in the cloud as well. Whether or not you're looking to migrate off of Oracle, I think this is definitely an alternative to consider, especially for a proper database as a service, because that, from an Azure perspective is fairly difficult, right? You're probably either procuring licenses to run them on Azure IaaS, but there's really no managed service option for you. And then lastly, something that Ben had touched on when sort of looking at availability is bidirectional replication, or BDR. Factoring this in to sort of running your workflows in a continuously available fashion, this is something that we'll be incorporating into our database as a service as well. So I wanted to share a little bit about that offering with you, kind of in the context and lens of these critical questions, because a lot of these things are things that our teams have internalized, spent time on, and sort of built into our database as a service going forward. So with that, I will sort of ask you all on the next slide, if you're interested, please send us an email to sign up for the preview. We're launching August 16th, and if you're interested, just send an email, edbcloud@enterprisedb.com, and we'll be happy to get back to you, share a little bit more if you're interested. And with that, I just want to thank everyone for attending today and hand it over to Ina.
All right, thank you both very much. I don't see at the moment any questions in the question panel, but if you do, I'm gonna give it a few minutes for you to pop them in and we can ask them and answer them live at the time. All right, so I see Atar has a question. So we'll wait for him to type it out.
Must be a long question.
Yeah, all right, so I have, okay, so for Kinner, okay, the recording of the webinar, yes, we will be sending out the recording and the slides after the webinars to all the participants. So yes, you should expect that to be sent later today. And then, great, okay, so I see another question here. How can we achieve multi-region on Azure with LB using PG Pool?
It's really hard, right? Like something like PG Pool can help abstract the complexity of the database topology under the hood. But at the end of the day, PG Pool is like that lives in a region, right? Furthermore, you're not going to, with something like PG Pool, get away from the fact that you have a single writable leader, right? You've got a region, you've got data writing to US East and US West, for example. With traditional Postgres streaming replication, either US East or US West is writable, right? The secondary region is not writable. So if you wanted to do something sophisticated where you're, say, doing geo routing of incoming users to either the East Coast or the West Coast, depending on their physical location, you can do that just fine at the application layer, but your writes are still going to one of the two coasts for the data layer, right? That might be okay, right? If it's a mostly read application and you can issue your read queries locally to the region that you're on, that might be totally fine. But something like PG Pool is not really going to save you there. Where it can help, and I think most of the time we see PG Bouncer in these situations rather than PG Pool, in part because PG Pool is it's kind of complicated, is running the proxy with your applications, right? So we see a lot of architectures where you've got a proxy running with the application that is abstracting the database topology from the application, and then another proxy on the database side as well. So you can run a multi-tier PG Bouncer or multi-tier proxy implementation that can help simplify your application's view of multiple regions or simplify your application's view of multiple data centers. And that can be really useful, right? But at the end of the day, if you really want to do multi-region, you don't want to play games with sending writes across the country, you're in a situation where you need something like BDR to be able to write to both sides, right?
Got it. Okay, thanks, Ben. So I'm actually gonna move to other questions. And Atari, it seems like this is, if this is, you need more context or info, we'll gladly follow up with you afterwards. I see another question here from Harinder. So how about EFM? So can it work between master slave database distributed between regions?
Oh, that's a really good question. I think it can. I don't know off the top of my head anyone who's using it in that fashion, but technically speaking, I don't think it would have serious problems. We can follow up with you on that though. We can get the EFM folks to provide some feedback. That's a really good question.
Great. Another question from Nuts. So what is the best option for backup and recovery in Azure?
Ooh, that's a good question. So the simplest thing to do, so EDB, we are the maintainers of Barman. I think Barman is a really fantastic piece of technology that lets you do really sophisticated, cool things with zero RPO streaming to a Barman server, these sorts of things. It's a really cool piece of tech. It's not as well integrated yet. We're working on it, but it's not as well integrated yet into cloud object store back deployment models as I think we want to get to. And the Barman architects might disagree with me a little bit there. My bias right now, I think the simplest thing to do right now is to use something like Barman Cloud or maybe PG Backrest to do traditional wall archiving to object store. Right. If you send your backups directly to object storage, yes, your RPO is a little bit lower or a little bit higher. Sorry. Right. Your RPO ends up being about at the level of your archive timeout in Postgres. But you get immediate cross-region durability of your backups, right? And if you think about a cloud model where you've got you're already deployed in multiple data centers, a data center failure is not a backup and restore scenario, right? You're using backup and restore to manage things like fat fingering, which is, I think, where Barman server, like the traditional Barman model, can be really useful, and we need to get it better integrated in the cloud, or things like complete region failures. In complete region failures, you just want to be relying on the cloud's object storage. That's what they're designed for. They're fantastic pieces of technology.
Great, thanks, Ben. Let's see. So, Aisling, I see you're typing in for Neil a question.
Yes, I can speak to it a little bit. I think there's, Neil, to your question in terms of is EDB Cloud going to be really global or just USA? There's legal implications and legal implications for the data transfer between the EU, USA, all that. I think there's sort of two vectors I like to think about this. Like one is sort of the kind of the compliance angle in terms of like legality and what's required. So just to touch on that, we have a fairly aggressive compliance roadmap. So there's a few different certifications that come into play there, GDPR, and then as we expand, a few others. But for the purposes of our preview, we will be launching in a few regions, and at the same time, though, coupling that with sort of the strict security and compliance roadmap, I think helps sort of address like some of those concerns in terms of transferring data between different regions. In the past, like I know it's like certain teams have set up, for example, like an EU specific actual region so that customers have data residing in the EU and have operators actually addressing that. So those are things that we're conscious and aware of in terms of actually building out sort of our posture to actually account for like the legality of sort of the implication of global data transfer. Anything you want to add, Ben?
No, I would say that it's complicated. The legal status with Privacy Shield and some of the other things in the space is kind of complicated right now. As Aisling said, it's something we're very much aware of, and the architecture of the system is designed to support very fine-grained in-country data residency requirements. Right? We have customers who have these shaped problems, and a bunch of folks who have come on to EDB to help build this product have worked in environments, sort of database as a service type environments where we had regulated in-country requirements before. So we're planning for it. If it's a problem that you have, I think don't hesitate to contact us and we can talk in any level of depth about it. But it's difficult to provide a crystal clear answer given the complicated legal space.
Great. All right. So I think we're just right over time now. So I don't think we'll have enough time to go over any more questions, but please rest assured that we will be following up with those questions that are not answered or need more detail. But for the time being, thank you so much for joining the webinar. We will be sharing the report along with the slides via email with you as soon as possible. So with that said, thank you, Aisling. Thanks, Ben, and have a wonderful day.
Thank you.
Thanks, everyone.